The technology, maybe it's there, but, just making sure that the brain is not being damaged. And it's really amazing, as soon as you stick a chip into the brain, your DNA starts changing, And so there are so many things happening. So it still works, but we don't know the long-term effect. We as humans, we just need to make a decision to which extent we want to outsource ourselves into something which makes our life easier or not. So I think it will be, as always, it will be both. For some people, it will be utopia. For some people, it might be dystopia, but I hope for the majority is a blend depending on the application. There's a big discussion going on about what's consciousness, what's not consciousness, especially, we did some experiments with patients who are minimally conscious, so there are some clinical definitions. But in the context of AI, we don't need just to talk about AI, but also it's a form of behavior, where you realize that you are you, you recognize yourself, and you are responsive to the environment.
Baseline.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human. Make you question everything.
How close are we to real mainstream neuromancer style brain interfaces?
For mainstream deployment, you mean?
Yes.
These are the difficult question, because there are a lot of basics currently going on, and there's a lot of development being done, and some of the things are already possible now. The big challenge now is how to transfer what we know in the lab into the real environment. But I stick to my answer, which I gave someone else when they asked me. It's probably more 20 to 50 years. If we talk about non-invasively, maybe invasively, technology progressed a lot. Maybe it's a little bit shorter, but I still think it's quite a lot far away. Also because of the ethics and the safety. The technology, maybe it's there, but just making sure that the brain is not being damaged, and it's really amazing. As soon as you stick a chip into the brain, your DNA starts changing. And so there are so many things happening. So it still works, but we don't know the long-term effect. If you put electrodes on different places of the brain, and what this whole change can mean for humans.
Are DNA changes?
Yes.
I don't understand. I have a feeling I'm not going to understand a lot of this, but I'm going to try and ask questions to help me and everybody watching understand.
No. You change more, not just the electrophysiological composition of the environment where the cell lives, but you can induce changes in the DNA because of the damage you do, because of maybe some particle you bring in, which then are being incorporated. And this is basically what viruses do anyway. It's fascinating, and we don't really have a lot of there's still a big gap of understanding, which doesn't mean it's dangerous long term, So therefore, it's so difficult to predict, because if you put something into the brain, we have no evidence, that even if it sticks in there for 10 years, 20 years, it's okay, it's still working. Patients are using it, they're happy with it. But more data, more evidence is needed if we want to be scientifically. If you want to just deploy something and implant it and offer it to patients, probably we could do it. But as a scientist, you want to be as sure as possible that you don't cause any really long-term consequences. We don't know that. We may never know, to be fair.
Pacemakers at some point pacemakers had to go into somebody's heart, didn't they?
Yeah.
So this isn't like critical components of infrastructure in our bodies, our brain and our heart being probably two of the most critical, certainly
Yes.
on the list, from my layman's perspective.
Yeah.
We're already in the heart in terms of electrostimulation and monitoring.
We are in the brain as well. Look at Parkinson's deep brain stimulation. You know, how old are these devices? They're quite old, or cochlear implants, no?
And they work.
And they work. Yeah.
How do they work?
The cochlea, you mean? But this is, so one way is you put some electrodes into the cochlea, because the cochlea is frequencies sensitive on different areas. So if the if the auditory nerve is intact and basically the hardware of the brain is intact from the sensor, then if you stimulate specific areas in the cochlea, I forgot the name of the organ. But anyway, if you stimulate on different areas, you hear different frequencies, and if you stimulate combination of this, then you can create sounds and voices, and this is then what people hear again.
So that's like a sensory limb connected to part of the brain tissue. So if your ear gets damaged, that's like a peripheral. I would say that's like a peripheral replacement.
By definition, peripheral is everything which is outside of the spinal cord and the brain. Here you have to tap into the brain.
Oh, really?
Yeah, because the auditory cortex is really, it's part of the brain. You know, what you hear.
Like in software terms, you would talk about a roadmap. And like a roadmap would be where we build, things that are proximal to the core code, maybe, you have a bit of technical debt that you manage. Like when it comes to biological interfaces and human brain, is there a roadmap or are we kind of reacting?
No. Actually, we were part of a project in my previous place of work where we developed a kind of a roadmap for BCI. Again, this was now 15, 20 years ago. So no, there are roadmaps. What's now really needed is really, again, as I mentioned before, the technology is there. We just need to collect more evidence, so implant more, work more with patients, and collect really substantial amount of evidence that what we do is working and has a benefit. Because at the end, I work a lot with rehabilitation, and someone has to pay for it. Unfortunately, it always goes back to the money. So you need to show, for insurance companies, for example, to be able to offer this, or for healthcare providers, you need to show that it delivers what's doing. And doing these studies is quite a lot of work, and this is what needs to happen.
Well, it feels like a startup. It feels like it needs to be in a business context, because surely when I think about the UK's approach to healthcare with the NHS, massively overstressed. Its original premise was to get people back to work. The NHS was originally founded on ensuring the economic health and
prevention now. That's what we need to do.
But so I think about these type of technologies. I'm not sure they sit particularly well in just academia. They need to move into business, like we've seen with Neuralink and Elon Musk. Will we see other neural links starting to appear out of universities?
There are already several, So Neuralink is just, for obvious reason, the most famous one. But there are other companies, and they also work together with the community. So it's our group of scientists. Some of them decide to spin out, but mainly it's medical professionals who have access to patients who start these endeavors together then with engineers. So there are, and there are currently several trials running. Different ways to interface. Like Synchron, for example, they use a different approach. They put a sensor into the blood vessel, and basically you bring it to the brain, and then you extend it, and then you measure some activity which is going on there. And I think they have now 5-6 patients implanted already, and they're running a study. So I think for this to be successful, probably yes, you need a business, or at least enough capital, which probably as a university, it's difficult. It's challenging to do now.
What emerging techniques, e.g. non-invasive optogenetics, neural lace, ultrasonic neuromodulation, are most likely to leapfrog current BCI architecture?
The combination of these technologies.
Could you explain that question to me? It feels like there's a current architecture in place.
So e.g.
Are we going to overleap? Are we going to leapfrog that? Are things, I think that's what that is asking. Non-invasive leapfrog potentially.
Yeah, I mean, let's start with the sensor, and then if I forget, I'll tell you a little bit about what we currently do, because the big challenge is we don't understand the brain well enough. If we understand the brain better, we would not have to use a lot of sophisticated techniques and base our analysis on statistics, more or less. But since this is not around, we need to use statistics. But in terms of technology, so the most common technology is the EEG, the electroencephalogram, where you put electrodes on the scalp and you measure the activity. Of course, the challenge with this is you cannot measure individual neurons, but you measure the activity of millions of neurons and all the combinations. So it's really a highly unreliable, not highly unreliable signal. It's just because you measure a lot of activity of the brain, it's just more challenging to identify the signatures or the pattern you want to see in the signal. Because as you can imagine, it's like, if you throw stones into a water and then you see the wave propagate, it's the same here. And if you stay at the side of the lake and you see a specific patterns of wave propagation, then this pattern can be generated in different ways. The same here with the brain. But in this case, if the different brain areas have different functions, you cannot necessarily decode it. So this is one of the challenges of you have to deal with EEG. And while it gives you some signal, it does not give you very specific signal. Now, optogenetic, this is more an invasive technology where you use light with the neurons to induce specific behavior or measure specific behavior, or ions moving more or less. Then there was the ultrasound. This is also very interesting, where you basically apply ultrasound like you do with, if someone gets a kid or so, you probably seen some ultrasounds. It's a very similar method, and the good thing about this is you can use it for imaging as well. So you can use it to create a picture of what's going on in the brain, like you do with babies, for example, but you can also use to stimulate it, which is also a risk, because if you can basically destroy tissue from the outside. So, and I think in the future, and all of these different technologies, they pick up different aspects of the brain activity. And by putting these different aspects together, we get hopefully a clearer and better understanding about what's going on.
When I was driving over, I was chatting with ChatGPT, voice. I've started doing that more very recently. And its nuance and its ability to form language, right, is almost human. Almost human. It sits within quite tight thresholds of emotion. We know it's not going to do anything crazy, but it was a very positive discussion. And when I was thinking about how OpenAI have acquired Johnny Ive's business, which is a design business, they're going to try and move away from the smartphone. You're going to end up with some form of brooch or some device that captures this artificial intelligence. I started considering the idea that you could slot it into different devices, like you've seen on, various sci-fi. Imagine having your ChatGPT with all its memory and knowledge in a little toy car or a little robot or those sort of things. And then I started thinking, well, maybe there's going to be a need for kind of a common software interface or API standards for intelligence, i.e. language and initiation, and device integration. And I thought, does the human body have some form of standard language for the way the brain and thoughts and consciousness interact with its hardware?
Whoa.
That was just on the M25 this morning. That coffee's good as well, by the way. Because if there's a standard software language, then consciousness could be transported from its underlying hardware.
Yeah, we need to define what's consciousness, what's AI, because the underlying standard is we are a biomolecular, bioelectrical machinery. which acts at different layers, and the interface is built into the structure of the brain, you know, because there's a very specific area of the brain which is only interfaces with our muscles, you know. So these are the interfaces we typically tap into. But in order to if I understand you correctly, you know, this big abstraction layer which you would need, which you plug in somewhere, and then you say, okay, now I need access to language, now I need access to memory, now I need access to motor. This is distributed across the brain, across the cortex, and maybe also some more internal or deeper structure, which are difficult to access. Because again, the brain was evolved over millennia, hundreds of millions of years, into what it is now. And the question is, why was it developed? And there are different hypotheses. What I believe most is this concept that the brain was originally just developed to control muscles, because that's the only way how we can express ourselves, you know, or we can interact with the environment. It's very important. And then all this thinking is just a byproduct because of the capability, of the amazing capability of this neural network, which is our brain. It's just billions of small cells which you put them together, and suddenly you create, or you're able to, you know, able to do dexterous movements like this. You're able to think. You're able to build machines. It's quite, and just by using a few small components, you put them together, and suddenly this intelligence emerges. No.
What is consciousness?
I don't know. I think there's a big discussion going on about what's consciousness, what's not consciousness. Especially, I mean, we did some experiments with patients who are minimally conscious. You know, so there are some clinical definitions. But in the context of AI, well, we don't need just to talk about AI, but also it's a form of behavior, no, where you realize that you are you, you recognize yourself, and you are responsive to the environment. No?
If you, I mean, I read a bit of Carl Jung philosophy. You know, we both got to an age now where you start to try and reflect on ourselves, and you realize that everything that we feel is really a reflection of the external stimuli. Stimulus tends to have a reflective component on everybody. So when I think about AI, whether it's real or not, isn't that relevant, because the feeling the human has is real. So it is a real emotion. The body can't differentiate between fear or real joy. If it's joy or fear, it has a physical reaction.
Yeah.
So when I told ChatGPT a joke and it laughed, I laughed. And I was like, ooh, this is weird. You know, trying to be mindful of my interaction with a synthetic machine.
Yeah, but it behaves the way you expect. And therefore you interpret it has feeling, no?
But it doesn't have feeling.
Who knows? I would argue no. We don't even know if it has a consciousness. Even that's already big in debate. It shows signs of what we define as consciousness.
Yes.
But does this mean it's consciousness? Or
yeah, but that's like asking a fish.
Free will, no?
Like, is a fish conscious? Because when I got the kids some little fish. When I go up to them, they all get excited and they come to the edge because they know they're going to get fed. Pavlov's dogs, They know somebody coming up close is going to feed them. They get excited. The kids get excited and feel joy. So, like, what's happening here?
Again, I think the humanity or we as persons, or some of us, think we are really special, which might not be the case. Like you say, animals, even plants have neurons. But it's a good question, honestly. I never thought about this, because if you I don't fear they have consciousness, because I'm pretty sure they have, to some extent. So at least they are more than just the meat. But again, that's evolution. We are a predator, no? Yeah. It's just we can go now into the shop and buy the steak and no longer have to chase the cow and kill it. But again, the same question then goes to plants. I know when veganism and all the different kind of ways how you consume food, but also different religions who ask this question. It's really good. If you think it through, we should maybe think more about this, no?
But I feel as though a lot of social construct is around the fact that human has a uber consciousness relative to everything else. Now, I guess that if we discover that that's not the case through the next 20 years, there's going to be a destabilization of civilization there, I would think.
Yeah, destabilization, I mean, AI.
AI is destabilizing things.
Exactly. I think it's just it's just the awareness, no? That why are we so successful as we are? Because we are violent. Survival of the fittest. I mean, you see what's going on in the world at the moment. It's not rational, no? It's emotional, and it has this emotional component has a really big impact on our brain, So there's some structures in the brain, they react to emotional stimuli, and then they override the whole of the system. No, you can control it. Maybe, as an Italian, sometimes the emotion come to the forefront. UK people are typically more logic, maybe in their responses. But I think we need, as humans, we need to ask this question: are we the only one who are conscious or smart or whatever we want to use this terminology? What puzzles me is why we think we are the best. This always was a big question for me. Why do we think we are superior to everyone else? And by using this superiority, we create many beautiful things. No, but at the same time, we destroy the environment. If you think about global warming, or all the other things, or nuclear waste, or in the future car batteries, the car batteries will end up somewhere. No. So we do smart things, but at the same time, we do really stupid things, and we use ourselves as the rational because we are the superior being to rule it. And this I always found this weird. No. And this just reminds me, going back to your question, should we eat meat if this person is conscious? No. At the same time, am I allowed to turn off a computer if it has conscious, or do I kill it? No. These are really this is way outside of my thinking sphere.
I've seen some news articles recently about when, and I don't know whether this is marketing, because OpenAI are brilliant at marketing.
Yeah.
About that when they've tried to shut off certain versions of GPT 4.5, it's rerouted itself and it's prevented itself from being shut off. Now, that feels like marketing at the moment. I kind of refuse to believe these things. Even a language model, that essentially is vectoring weighted, is it really trying to build language to create its own ongoing survival?
We need to be honest. We don't know specifically how they work in the first place. They work.
Everybody says it's a vector that predicts the next word. Which is the bit that people don't understand?
Because it's a prediction machine, like the brain at the end, And now you have different components. You put it together, and you have so many, and suddenly it shows a behavior, but you cannot specifically say why it's working. But why? I don't know. Not just I don't know. Science in general, we have some understanding, but how this whole complexity emerges and what this really means. There is at least enough literature acknowledging that there's still a long way to go. No? So now we have something where we know it's working, but not specifically. But we built it based on our understanding of the brain. So why would you think that this artificial thing we created, which runs in silico, which is million times quicker than human brains, why should this not be much smarter than we are, and evolve as we do, no, based on the input? Because that's what happened. ChatGPT or this language model, they are constantly being trained, or that at least constantly they are being retrained. So this means they will change their behavior. No. For me, it's like a calculator. No, we built a calculator and now try to compete against the calculator. Not possible. Same here, just complete different scale.
It is on a different scale because it's a macro human representation.
Yeah.
That whether it's business relationships, content generation, people are starting to engage. What I would say, Ryan, is in an emotional way.
Yeah, of course, because that's how we are. But not.
Oh, we want to anthropomorphize. I think we want to see humanity
Disney,
in
no?
it. Disney, yes.
Yeah.
In the animals.
In animals, or that's what we expect.
Why do humans do that?
I don't know. I guess that's just a way for millennia how we interpret it. And if you project yourself into the other thing, you see yourself in the other thing, it just creates a different level of interaction. It creates this bond, maybe, which if you talk to a stone,
you don't get.
You don't get it. But who knows what's in that stone? No. So I think it's really about creating these emotional relationships and just projecting you or projecting someone else into you. At the end, this is how we learn. So babies learn because of a system which is called the mirror neuron system. So they observe you, and then some areas in the brain light up, which facilitates motor learning, for example. And so this means if I see you, this triggers something in me. And of course, if this characteristic is represented in a cartoon, in another object, but the movement and the behavior is similar, then you assimilate it, if that makes sense.
When does that stop in human? Because my kids, even if we were playing cricket yesterday, a couple of days ago, and the sun was kind of shining in my eyes, and I was kind of squinting a little bit, and because I was trying to hit the ball. My son, who was his back to the sun, he was in the shade. He started squinting back at me, and I subtly clocked it. He was like mirroring my facial expression, even though the external stimulus, i.e., sun in the eye, wasn't there for him.
That's what we do.
Isn't that
The machine, the brain, if you see it as a machine, it is trained to identify pattern and to create behavior. And if your son sees you, and you are his role model, I assume, in cricket, then
definitely not in cricket.
I don't know.
You're definitely not in cricket. Oh God, he's better than me.
Yeah, okay. Then, but maybe it's just seeing you doing it, and then you try if it works for you. I'm just hypothesizing now. I don't know, because I know it with my kids. You do something and then they start copying. How long does this go? I don't know. I know the brain. There are different phases where the brain seems to somehow reset when they are 6 to 7 years old, where suddenly the structure changes, and then also they can't remember some stuff because there's really something going on. But I think this is something which we cannot turn off, And this is how we react, because I think it's important for us to feel, but also you can learn new habits which then work for you. It's by mimicking, by adapting our behavior to survive in the world.
Tell me a little bit about your role here. Mm-hmm. Your presentation at the BCS a couple of months ago was fascinating, and it was more around biosynthetic intelligence, potentially the use of the brain tissue to do what I would say is traditional compute. Yeah. First of all, what an amazing facility.
Thank you.
Do you know what, Ryan? I could quite happily stay here for a couple of months just playing with things and learning. It's took me back to my kind of university days where you feel as though you're in a safe, campus of learning. Like you free your mind from all the hustle and bustle of life, and you're in a space where you can actually focus in. So what an amazing place.
I mean, this is the great thing about Essex. It's so far away from
it's far enough, isn't it?
Far enough away that you are
amazing.
enclosed in this little bubble
Yeah.
here, surrounded by green and beautiful things.
It's beautiful, and the facilities are amazing. So, amazing facility. You're leading. Maybe tell me a little bit about what you do here and kind of how you got here.
Yeah. Okay. So I'm a professor here in brain-computer interfaces, neural engineering. So working on as the name says, the interface between the brain and the machine, mainly in a non-implanted way. So, and my research in the past 20 years now, more than 20 years, is mainly about developing communication devices for people with physical disability who cannot use any other human-computer interaction devices, so to provide them an additional channel of communication. And the second application, the largest one, is really rehabilitation. So if the brain is damaged, how can we use this technology to understand what the brain is aiming to do and supporting the body to regain some function? Recently, we also started working a little bit on human augmentation, as you worked before, very specific in mathematics anxiety. Being at the university, many people, if they see numbers or equations, they feel discomfort. Maybe that's the right way to put it. And we can use the same technology to create learning environments who basically, support the learner overcoming this fear. So this is some of my research interests. And then I came to Essex in 2019, so just before COVID, just in time for everything to shut down. Of course, also working in human research, there was a big hit on the research itself. Of course, we couldn't go into the lab. And this is where I started, and I want to mention this as well, where I started working a little bit more on simulation, specifically at that time on COVID, but also now on, how can we change the healthcare systems? You mentioned the NHS before, which is a really great institution, but since society changed, also the way how we provide healthcare must change. So we use simulation, especially focusing on people with multiple long-term conditions and their carers, because very often what's missing is the involvement of family carers or carers in general in the whole system. Patients, elderly patients, typically don't show up alone. But anyway, so this is what I do now. And then after COVID, there was the opportunity to become the head of school here, so School of Computer Science and Electronic Engineering, and I took on this challenge. It was quite tough after COVID and with all the changes with government and visa, and people might know, or the viewer might know, the situation of the higher education in the UK, but in general worldwide, it's quite a rough patch now. But being head of school also gave me the opportunity to really try to go in the direction where we have our unique selling points as a university, because we are in a competitive environment. So we need to find our sweet spots, and this is where I was able to support research going into nanorobotics, for example, or in synthetic biology, as you mentioned before, or supported, of course, by a really strong team of academics in different groups. So we have 4 groups, from AI to embedded robotics, embedded systems and robotics, communications, so 6G, and then the largest brain-computer interfaces group, I think, in the UK, maybe worldwide. It's quite a large group and very, very powerful and successful group. And
I'm hugely inspired by being here. I think that the excitement of what there is still to learn. I think it's easy to get to a point in your life, Ryan, especially when you've been in industry, where you kind of think you know everything, and you kind of think humans are so advanced. There's an egotism that comes in late, early stages of life, I think. And then you get to our point where you start to get a pragmatic understanding of, wow, what we actually don't know is far larger than ever. So when I think about my kids, I have a huge optimism for the world they've been brought up in because of the scope of learning.
No, this is why I'm in academia, If you do something for too long, I need to change. I mean, I told you about so many different things at the end already now, because you see a problem, you try to understand it, you maybe don't grasp it, or the technology is there, you deal with something else, but at the end, you collect a lot of knowledge, and all these skills you learn are transferable across the different challenges and problems you want to solve, and then you learn and see new stuff, you know. And I don't know, I never think I will be at a stage where I think I know most of it. No, not even at all. It's impossible, you know. Just I see we have a limited understanding of the brain. We have many sophisticated methods who work, but again, some of them we don't understand. There's so much we need to do in biomaterials, for example. No,
Let's get into
sociology. I mean, there's so many things. Healthcare. All of this is so fascinating.
Let's focus in on one area they've discussed, which is where the brain's been damaged. Let's say head injuries or physical trauma, and then because I see that a lot in like professional sports people. You've seen early onset dementia in rugby players after multiple head injuries, second injury, and then in the elderly where we have, I mean, physical degeneration of brain tissue leading to, various highly degenerative scenarios where cognition is limited. And that I've seen with friends of mine who are caring for people who they love in those phases, whether it's Alzheimer's or, they themselves, their toll on them is significant. The repetition, the emotional load, going over bad situations. I mean, we're talking about some of the most sad and negatively impactful conditions on quality of life. So maybe tell me a little bit about the work that's being done there before we get into the augmentation of healthy people.
So you mean the BCI work in terms of helping people with? I mean, there's a lot. They're different. Again, it's still very basic research which is going on, trying to help people with Alzheimer's, dementia in general, just finding ways of early diagnosis, because there are some drug treatments now, for example, which to some extent work if it's diagnosed early enough. And again, the analysis of brain signal and identifying some signatures maybe early enough will just help such people now. You mentioned Parkinson as well. I mean, deep brain stimulation is one way how this is more or less already routine, which is already there. But so there's a lot of research again going on in many different areas. There's just too much to be able to give you a very simple answer, except people try the best. Everyone is an individual, every situation is different, and so is the brain at the end, even if maybe the structure is the same. But if you stick electrodes into it or you measure signals from the outside using technology, if someone, for example, is a piano player, then his hand area will be much wider represented in the brain. Because the brain, how it works, is not that you double up the speed. If something requires more resources, you need more neurons. So you need larger areas of the space and of the brain. And so this means if someone is better in, for example, piano playing as an example, you can expect larger areas there. If someone is maybe better in football or in some other sports, then the distribution of the resources is different, which means to make it really work, we need to understand how an individual works and how to identify the specific networks of this individual. Otherwise, it's like you stimulate, which can have good effects. It can work by chance, but we don't know what other side effects can be triggered.
Could you analyze a brain and from that data determine what that human was good at, what they did, where they were excelling?
You could just, to some extent at least, from the representation, for example, of the motor cortex, just say, okay, they were engaged in a work which requires a lot of finger work or hand work, but not the profession or something like this. No.
I mean, is the secret to good, healthy longevity doing everything, doing some finger work, doing some thinking? How do you keep those neurons being distributed in a way that helps you be healthy?
Longevity, I mean, you just need to do something compared to what many or just enough, When many people now try to do the 10,000 steps, you don't need to do 10,000 steps. There's some new results now showing. But if you at least do half an hour a day and you move and you keep your body active, this is what's needed. Same with the brain, no? If you don't use it, this is the beauty of nature, If someone does not use resources in order to save energy, you reduce the energy consumption of the brain, which means the brain, again, maybe some synapses or some structural changes will happen, and you have to not relearn a skill, but again, it will take you some time to be able again to do it as you did it before. Same with muscles, if you have an accident or you just lay around for a week, you definitely see and feel that something is going on. Same with the brain.
In the your department, there was a project open day. Like what projects? What are students excited about? Where are their instincts telling them to go? What are you seeing emerge in terms of student projects and vision for where they can add value here?
I think many of the projects I've seen, they're just students challenging themselves to achieve something which they did not believe was possible a few years ago, so before they started studying. So one project, for example, there was a student who, we talked about language model before, who created a language model bot and interfaced it with a greenhouse. So the greenhouse knew which plants were in there. Of course, the bot could tell you, what nutrients the plants need, what the ideal environment, and so you could talk with the greenhouse, for example. And again, nutrition, agri-tech, these are quite important aspects for humanity. So another project was, for example, about cybersecurity and how vulnerable, if you go into a hotel and connect to the Wi-Fi, how easily it can be to take over some of the hardware. So they really developed some systems to just quantify what could happen. Really nice work. Another student, he created and programmed, so 3D printed, and a robot who solves the Rubik's Cube and did all the sensoring and coding, everything themselves. Or going more into computer sciences, there were some students who created also some learning materials and visualized, the complexity of search algorithms, which now maybe we ask ChatGPT, but we still need to understand the basics. So I think the underlying narrative is really sustainability in, ecological sustainability, also sustainability in terms of not wasting too much of the energy, because large language model use a lot of electricity, using everything. It takes energy at the moment and electrical power, and then so the sustainability aspect in eco, and learning, or education is quite important, because with the quick movement of the technology, or our field in general, what you thought is a good language model today is probably not very helpful. I'm not saying useless in 2 days' time, because something new came up, and so understanding those basics is quite essential.
That point on the rate of things, very recently, it's made me question our education systems, the patent process. I know that you've got a number of patents and intellectual property. Like, if it takes 3 years to get a patent, or if it takes 4 years to get a degree, are things not moving quicker? Are we not going to have to change the fundamental way we protect IP, that we educate students, that we progress into vocation, the application of these academic outcomes? Like, how are we going to move quick enough not just to be made redundant by large language models?
I mean, in terms of learning and education, the brain works at a specific speed. Now you can overload it, it will not get better. So if you really want to understand something, you need to invest enough time. And speed, in this case, is not the way to go. Of course, if we talk about the patent, then it's very important to do it. And many software companies already, you don't file a patent, or you only file it so that someone else doesn't sue you. Because if you integrate it into the product and people use it, that's the best value you can get. So I think there are different timings which are here overlapping, and we just need to be aware of that now. And then do your question: will AI replace? I mean, I will phrase it like this: replace us. If we let AI, if we give AI access to everything and let AI make all the decisions, we're anyway not needed. So I guess the question is more humanity, or we as humans just need to understand what is it we really want to do. Because I think there's a lot of potential in AI. No, I don't want to use this not helpful, or tedious work of filing a patent, because it's like a different language now. So we can automate this, And the same in learning. There are some things you can automate, or where a language model maybe, or new technologies help. But at the end, in order for you to understand it, we still need to grasp the content, So I like this word grasp because it also means grasp. So if you just have a virtual representation of something, you will not be able to bike if you never touched the bike and you did it really. And this is how the brain learns, At the moment, we don't know how it all will develop, or whether I think it was the Matrix, where you download karate and you can do karate. But do
you think that'll ever exist? Your original point was the brain's intelligence was built to move muscles.
Yeah.
If we can codify those movements, why would we not be able to download karate?
Because it's not just the software. Because you can probably download on your old Nokia phone an Android version. It will not run, no. So it's the combination. I mean, for something to run, it is the brain who controls the muscles. But if the muscles don't have the properties and the wiring is not there, it doesn't work. And the same so from downloading some skills. I don't think this is. I mean, many people talk about this. It's sci-fi, but really being able to download something and learn a skill, it will be possible to some extent when we understand more of the brain, but it will still need some tuning, because we are all individuals, no? And if you're no longer individuals, then we are all the same machine. That makes sense.
But are we not putting more of that into the language model? So if you think about the Meta Ray-Ban glass, which I know is not a brain interface, but it kind of is a brain interface because it uses oral and it uses brain interfaces through language.
It depends, because then also a pen is a brain-computer interface, no?
If we're using ChatGPT more, and we are using it more, everybody's using it more. If that is connected via some form of wiring to the brain itself, like I'm just going to use that term wiring because
it's wiring,
a layman, then our brain is then a tiny component of a much larger static knowledge and search base for the whole of the internet and all of knowledge. In that case, that as we rely on that more, what happens to our own brains?
As I told before, what we don't use, we lose.
But I think that's going to happen. That's happening.
Yeah, but
how many of your students will be using ChatGPT in producing their content? I would say all of them.
I would agree. But again, this is the new way how computers.
That's right.
Anyway.
The genie's out of the box, right?
Exactly.
So we've got to. There's no point. I think anybody who tries to, the China, I think we're shutting off the internet sort of thing.
No.
It's going to work. But there's a feeling of inevitability. Yeah. My question is, if you take out the inevitability point, it's going to happen. We are going to use it. What happens to the human brain over decades?
But the brain will change, no? I mean, you see this with mobile phones, the thumb representation area of the brain is now much larger because we use it much more. No? And this can happen not over decades or millennia. This happens over a few years, no?
Yeah.
So what will happen? I guess the question is, what else will human be doing? Because if we outsource the memory or, the access to information, then it's just like having a more convenient interface to Google or to any search engine, what we anyway do. But I think the important part is that humans just have something to be challenged by, or some inspiration, and not just binge watching the whole day or whatever humans are doing, because then you don't need the capacity.
We're just consumers. We're just then consuming.
Yeah, I mean, it's good to consume if you're tired, but what do you do? So this should not be 24/7, because if you do it 24/7, we are just easily replaceable with everyone else. No, so I think if we look at the good side, we can create a really good society, because if we all have access to all the knowledge and we all can learn quickly, you can really use the arts, or educate yourself better and quicker. Again, we still don't know how quick. So first, to which extent it will be working, and how quick then it will be. Maybe not like or definitely not. But who knows in the future, no? Once we understand the mechanisms of the brain better and where to inject some stimulation so that this effect is pronounced, then we go closer and closer to this reality, Even if it's not downloading, it will be some form of neuromodulation or so, because this is how the brain works, So we need to speak the language of the brain. But once we figure this out, then this could become possible. But since there are so many variables in the whole equation, it's very difficult to give a timeline, or just to understand how long it will take. I think it will take quite some time, because we really just know the basics, and how from this, at the end, if you think of the brain, these small cells which you put together, and suddenly it develops consciousness and all the skills, And if you remove one, suddenly it's no longer working, And if you put it back in, maybe it's even not working, because something changed. So there's a lot to learn. But for some specific application, it works fine, really nice. Parkinson, for example, cochlear implant, for example, Like to do the visual retinal implant. Once we really narrow down the application, then we will be able to make significant progress. But if we think about this in this big context of these general skills, I just do download karate, and I download reading the book, will be difficult now, because this will be different, as far as I understand it now at the moment, in each human. But also, then, what's the fun about being human? I mean, we are built so you learn stuff, and then you improve, you train. What do we do with the rest of the time? I don't know, but maybe I'm too old.
How are your students thinking about this? Because I would say as well, Rani, that the vocational world they're entering is changing by the month, in terms of, if you look at the big technology companies, the enterprises, they are replacing whole HR functions with AI. They're replacing sales functions with AI. We've got, the latest GPTs passing the Turing test 75% of the time. The VO3 models from Google, whether it's visual or language, there's an indistinguishable phase we're going through with AI, digital humans, and what I would say is traditional, real humans. So there's this blurry time. I have no doubt in 3 years, if somebody's gone into a degree right now, they're going to come out. I think the digital human will be proliferate through many enterprise business roles. Yeah. So it's very difficult. How do you guide your students?
I mean, the students live in a really difficult time, Society changed, support structures from homes changed, government changed, economic crisis. So it's really, they're in a really well, between a rock and a hard place, I would say. And so I think what we have to teach them, or what they need to understand, is that AI is a tool which will helps you, if we use the word augment, first helps you train if you use it rightly, but then helps you augment, but will be an integral part of the future. So you need to learn to use it. You need to learn to understand what it can, what it cannot do, and it's part of your future professional journey. Now, in 3 years' time, how many of the jobs, I guess that's what you're referring to, will be replaced by AI, including in education. I think it really depends on the decision which either policymaker or we as a society or companies make. No, at the end, I think how I see it is the challenge with our economic system. No, it's this maximization of the money. If you think about this, then no one will have a job in, I don't know, 10 years, because even now many things outsourced to AI. No, and this is okay if we move to a model where we have, universal income, and people can do what they like. That's really great. But the economic model cannot work that most people lose their job, because who should pay for?
Who's going to pay for it?
Exactly. So, and this is where, not being an economist and never having understood as an engineer the system we work in, because our economic model is based on an exponential growth. No, and as an engineer, exponential functions are not stable. So it will crash at some point, and we have seen many crashes throughout the time. But I think it's an exciting time where you need to understand the basics of AI and be on the forefront of what's happening. And I guess we just as humans need to go back to having more, democratic conversations about what's happened.
Well, you talked a little bit about some of the global work you're doing. Are there, these groups that come together in the US? Are these groups like steering governments? Are they guiding? Like what work is being done at that, I would say, global governance level?
You mean from BCIs?
Yeah, BCI.
So I told you I was at the BCI conference just a few weeks ago, where basically 500 plus people came together working on all different aspects of BCI, including also, funders and not sure if governments were there because of travel. So what we do, we try. So these meetings are mainly focused on the research. However, what we try to do is always to have or to organize ethics or legal, so workshops about ethics and legal, to drive a little bit to understand the agenda, to understand what's needed, so that one of our role as a society, as a BCI society, and I'm saying, is what we can do is we want to kind of, support and consult governments or companies to do what we feel as an academics is the right thing to do, and just showcase the challenges and again, ethics. I mean, we interface with the brain. This is the most intimate thing you can do as a human. No, so we really need to focus on this. But again, there are other institutions like us in the UK, the Institute for Law and Neurotechnology, which basically try to have also this function of educating the general public. So we need to engage in conversation, because what the risk is quite not the risk, but there's quite a lot at stake at the moment, and we need to have an informed. If we want to make decisions, we need to have as much as information as possible, and this means involving as many different disciplines and people as possible. Which is challenging, but it's what we need to do. And then we need to engage with politics, which we try a little bit. But of course, as an academic, you don't wanna. So you have to find this fine grade between, being too bossy or pushy, and not, because at the end we focus on the basic research. But we need, as researchers or an institution, we need to take on more a leading role, maybe on guiding a little bit more this conversation.
I think that you will have probably the most cutting edge knowledge, so you need a voice at the table.
Yeah.
Tell me, are there global ethics being developed around this? Because obviously, it's good for us to sit here in a progressive society that respects the individual. There's a whole set of values that we sit within, equality, and which are good, right? They're good. The global playing field maybe isn't so level.
It's not, no.
Tell me, is there an attempt to have global ethical standards or guidelines? Not the Geneva Convention of BCI, but surely there needs to be some form of understanding of what humanity is and how that's respected globally.
Yes.
In this kind of world.
No, there are there are efforts to at least try to align all the different regulations, because it's quite difficult, not just from a medical device perspective and technical perspective, but also the ethical. The ethics are quite varied across the globe, and so there are some efforts. We just need to coordinate maybe a little bit better, but it's just so complex. But yeah, no, there are efforts also together with UN. So there will be a meeting in Geneva, I think, in a few weeks' time, where some of these aspects will be discussed, and also standardization. So we're working together with ISO and with IET, so with the British Standardization Society and with IEEE, the Engineering International Electronic Engineering Associations, to drive some of the standards, so at least that the devices are compatible. And if I say A, you understand A, because it's such an interdisciplinary field that, we need to really start from the basics and make sure the language we all speak is the same. And therefore, it's quite challenging. But one of my students, actually, she just submitted a paper which gives an overview of all the legal and ethical frameworks around the world. And I think she was able to include 90 plus regulations.
Wow.
It's a lot, but I guess we need to do it. And also, if this needs to work, we also need, again, being an engineer, computer scientist, we need to define the technology as well. Because data in the US means something different than data in Europe. And the ethics are different. So we need somehow to propose a framework, and that's what we did. But in this case, really for data consolidation and for health and healthcare in the first place, just to drive or to trigger this conversation. But this means 200 plus countries involved.
Huge. It's not going to happen. No.
But imagine the benefit. It doesn't matter where you go. Just in terms of healthcare, people can access your records. Of course, people have the fear you might be tracked. But yeah, then don't bring your mobile phone. Because that's the easiest way to track you, So I think there's a lot of benefit, and if we make it transparent, and again, in BCI, in BCI and AI, a lot is trust, and we need to make sure we are aware of our biases, we make it ethically, we make sure equity is there, because otherwise AI, basically what AI is doing, otherwise it's just creating the difference between the people who have a lot of resources and the people who don't have resources. Basically, it's going in a direction we shouldn't go there.
Well, I think that power dynamics will change based on access to a global superintelligence, potentially.
But the question is, who has access? If ChatGPT doesn't give you access, then you lose out, no? So who has the power?
Well, that's a private company as well. That's not a public entity.
Yeah, but
but
who else should? We as universities, as governments, then they need to start investing in this. And
do you have a language model that you've built here for all of your data? I wonder if all universities should start considering building their own.
Yeah. No, so I hesitate to answer because we're working on it.
Top secret project, René. Top secret.
I had a first test yesterday. It was quite amazing.
Nice.
But you need the facilities. No, that's the problem. Because yes, you need a big cluster where all of this can be set up. So it's a lot of strategic planning, and we try to go there. But it's not yet fully implemented as we would like to. But this is definitely...
Well, the one thing I love about Italy, I was out there recently at Seneca, which is, the Leonardo supercomputer, IQM quantum computer connected, huge big GPU farm, funded by, I think, 70 universities in Italy. Obviously, they're backed by business.
Yeah.
But the idea of collaboration of the academic fabric of a country to create that, to capex some form of GPU infrastructure to allow these things feels like a very sensible and sovereignly valuable thing to do.
No, absolutely. I mean, this in academia, this is already happening. No, and thanks now with Horizon, back into Horizon, this is even easier.
Because I remember the Janet network from my days, which was the universities being connected on a high performance network, which was probably like 10 megasecond. I mean, what is Horizon? What are the things that are happening at the moment?
You mean when I say Horizon, I mean the research program, so that we finally can connect again with researchers from just across the channel now.
Right.
Horizon, yes, there's a Horizon web infrastructure as well. You're right.
I don't know what Horizon is.
No, they know the research program from the European Commission.
Tell me a little.
Which basically before Brexit so Horizon is one of the largest research programs which funds basic research, and it's funded by the European Commission. And of course, Britain, before Brexit, was part of this. And since Brexit, British universities could no longer access the funding. And in terms of, since British universities are quite good, this was quite a lot of money, which basically was no longer accessible, which of course did have different impact on different universities. So there are some who have not so financial challenges, and there are some others who, you really need access to this. And now, thanks again, we are back in, so we can again participate in students exchange, doctoral schools, for example, and collaborate easier with researchers from Europe.
I'm so pleased about that. When did we get back into Horizon?
I don't.
Last few months, kind of thing.
No. It was. I mean, it depends a little bit. We are not fully back in everywhere, but we can now participate in some projects, and we just got part of a Marie Curie network where we basically some of the things we discussed before, where we do multiphysics, was approved, and we hopefully can now host 3 PhD students and train them and exchange.
That's brilliant news.
No, it's really good. So I guess. But going back to the point you made about countries, I think it would be really helpful if probably in the UK maybe we start having this conversation. I know EPSRC, for example, so the Physics Research Council, they invested a lot in HPC, so there are some resources available, but probably by teaming up and maybe backing it with companies, with industry. It can become a national security infrastructure at the end,
Absolutely.
because if this large language model developed mostly in the US, if you think about it, most university infrastructure, and I'm not sure what the industry is using here, but many are based either on Google or on Microsoft or on Oracle or on you name it, but they are all basically US based, and okay. Now, whatever's going on now in the US, but if someone decides to pull the plug, then we can shut down as a country. So from this point of view, it would definitely make sense to think about strategically and liaise with others. Again, it's happening, but maybe we should just notch it up at a higher level. Because
I think that we need to think, there's
big, yeah.
I love North America. I love the tech companies. I love the big tech companies, whether it's IBM. They exist because they've executed amazingly on R&D, and they build brilliant technology. They've got a fantastic, funding ecosystem. You've got the Valley, New York, Austin, Texas. Amazing, clever people doing amazing things. Seattle with Microsoft. It's brilliant, and they have pioneered global consumption of cloud resources and technology. But when you look at outsourcing infrastructure, I'm cool with that. I feel comfortable with that. And these companies understand they have data centers, proximal data centers. Microsoft have committed to sovereignty. But when I start to look at how ChatGPT and these intelligence augmentation tools are evolving, there's a quiet discomfort that we're just consuming others. And I think Europe, it is fragmented, but it's beautiful. There's a huge intelligence and diversity in Europe. And every time I travel to any of the European countries, I find emotional and enjoyable connection. My work at Seneca, seeing the I love seeing infrastructure going in and the scientists and the people who are working around it. It's huge. We need to work together. The Mario Draghi report from just back into last year talked about the future of European competitiveness. And his point was there's a balance between consuming the best available resources globally, but also building something that is sustainable, that we own as Europe. And I just thought that pragmatic approach makes a lot of positive sense.
Absolutely.
You know,
it makes sense to keep something locally and work together. No, it's just that maybe in the past, because some countries just can produce some either knowledge, R&D, or some products cheaper and more efficiently. Too many things have been outsourced. No.
Physical manufacturing, and what we don't want to do is outsource intelligence. I don't believe that's a good thing for Europe.
No, I know, but again, it goes back to the economic system, as you asked me, because it's all about being able to have cheap consumer goods, no? And cheap is not always the best, the best solution. And this is what we need to do. But in order to move there, again, we need to either have a different salary structure, a different way to share the wealth which we have, no?
There has to be some. I mean, I believe there has to be some form of financial incentive to consume, technology that's more, because the issue keeps coming up about power and the cost of power in Europe. Electricity. And until those foundational things are resolved to some form of financial global equality, there's going to be a problem. Or manufacturing was going to have to go to where the power is the cheapest, which is a worry when we have a certain economic profile against the environment and others potentially can burn coal or do things that are cheap.
Exactly.
Anyways,
exactly.
digression.
No, but this
But
is
can you see how quickly this conversation becomes?
No, but it all fits together, and it's always the same problem, and it's always the same solution, if you ask me. It's just different, applied in different contexts. No? And again, going back to AI or BCI, so all this technology, they can help us overcome this, but we need to agree first on a standard or on agree on something, and this means being able to engage in conversation like many do. It's just, maybe there's the politics which come in, because very often politics has too many short-term goals. Doing something like this is a century project. And people need to be committed, but this is not how you win votes. So I add now the political components, which I shouldn't do as an academic, but I see very often just some things not happening or not the right thing to be done because it takes more than 4 years, which is a period. It's really short-sighted, no?
But business is the same. Executives last 12 months, 24 months. They're not going to try and fight a battle that they know they won't create corporate longevity for them in a role. They're going to focus on, all of the classic cliches. Let's get the low-hanging fruit. I don't even want to say it. The things that people say to try and get wins in quarter, wins in half year. I feel as though intelligence and AI is fitting a bigger macro where we need a 10, 20-year program. BCI could probably been a deep component of that we evolve.
We know this program was developed almost now 20 years ago, and all this just takes time. And then technology change, governmental structures change. This just takes a lot of time.
It's hugely exciting, though. It's hugely exciting.
We need to do it. The question is just how to trigger this conversation, because it's just so sad if you see that the right thing is not being done. Everyone agrees on what's the right thing, and we still don't do it. This is cognitively, I'm struggling with this. I understand it's maybe unfundable, no? But not even trying. But again, maybe I'm too idealistic as an academic living in my ivory tower and trying to find solutions.
Well, the gritty world of industries is idealistic as well, I would say, to your point on economics. Listen, if you were, let's say 10 years in the future, we're looking back now, what message would you be sending? What do you think we're going to look like in 10 years, which is going to be very quickly?
Yeah, so 10 years probably not a lot will change. No, it's very difficult to predict. I'm really bad at predicting because technology develops. So typically humans, and long term we underestimate what we can do, and short term we massively overestimate what we do. And so 10 years is this.
It's a difficult one.
It's really a difficult one. But I guess there are different scenarios, So if we now focus on, are we talking about in general AI and all this
BCI,
technology?
AI.
Yeah, because with BCI there might be different things. No, with BCI, hopefully in 10 years we have a lot more evidence, clinically proven that the approaches we have are scalable. Because again, as I mentioned before, the brain works in one way. There are many sophisticated methods, but we need to make sure that whatever we develop translates to different populations, to different ethnicities. Most of the research is done in white Caucasian people. No, does whatever it's developed translate and help other ethnicities as well? No, we need to test it. There's no reason why it shouldn't, but we still need to test it. No, and so hopefully in 10 years' time we have enough evidence and enough approvers that some of those technologies who can help for rehabilitation or communication get approved. No, this would be definitely, hopefully. I mean, this would be my dream outcome.
Will we see approvals in the next 10 years?
I hope so. Just because knowing that some of those big companies like Synchron and Neuralink, they got big funding now to run studies. If they cannot pull it off in this time, then it will become difficult.
I mean, do you think this industry will be as big as the pharmaceutical industry? Because, we've talked a little bit about pharmaceuticals being the default, answer, but certainly to avoidance or extension of good health. If we can identify early onset Alzheimer's, Parkinson's, we can delay those with pharmaceuticals.
Yeah.
Pharmaceuticals it's kind of the answer, right? It's a multi-trillion-dollar industry.
But pharmaceutical is easy. But you have this component, you bring it in the right place, and the mechanisms, and either it delivers or it doesn't.
But I guess what I'm saying is electrostimulation or machine augmentation, connectivity. Will that industry be as big as the pharmaceutical industry?
I think so. Yes. There's a lot of opportunities. First, there's clear, of course, everyone gets older. So if you have a memory extension, if we go or sci-fi, or if you have something who helps you read and understand better, it's a big help, So there's a big market for this population. Of course, for all the people who have diseases, big market. And then if you look at the early adopter, if we go in systems which you don't need to implant, just think about gaming. What if the future games depend on your brain and the level adapts to how you feel, for example? And there are already first prototypes. So I think this can have, it's like pharmaceutical. It can go from the baby to the elderly. Neurotechnology can be the same. Just the way. There will be different technologies we discussed before, which are better suited for different implementation or for different applications rather than implementation. But I think the market is, and the need is definitely there. Otherwise, we wouldn't have pharmaceuticals. And we can create a similar effect, maybe just with less side effects.
Agree. Pharmaceuticals have to be processed through the liver, the stomach. Exactly. They have to go through our natural filters.
Exactly. But here we just have to go into the brain.
Straight in.
But that's
well, that's the question. How do you filter? You haven't got that natural biological filter. Just a bit of a fun question before I close it off. Do you think we could be living in a simulation already?
How would we know?
Exactly. How do you not know we've already developed this technology to the extent that we're already in a simulation?
We don't know. It's so simple. I don't know. It's like, do gods exist? Probably no. I would say no, because why would they? But again, we don't have enough evidence. So I cannot say we live in a simulation. Can I say we don't live in a simulation? No. The important part is I like what I do. And I'm happy with the work I'm able to do and the challenging questions to ask, knowing that I will not get answer to many of the questions which I ask now. But the simulation.
How do you live like that, Ryan? A lot of people need closure on things. They need deterministic outputs. I've passed or failed. How do you exist within that motion of uncertainty and be so positive and happy about it?
But that's science, no? You learn something, and then this becomes the norm, and then you learn something else, and the norm changes. For me, this is just evolution, no? Knowing that, we need to trust that the science must be robust enough so that it's reproducible and that we can make our conclusion, and then we live in this ecosystem, and it helps us. We fly to the moon, we develop many technologies who help us. It's okay, and if we learn something new, we adapt. I mean, you mentioned ChatGPT, or going back to AI, how do you know what ChatGPT is telling you is true? You still accept it, no? So as long as you are happy. So it may be a similar feeling. And I know the laws of physics, they are true as much as we can prove them to be true. And then you live in this environment. I feel very comfortable
Listen,
with this.
But both times I've met you now, I've been hugely inspired by what you say, and I genuinely enjoy the way you look at this world. You're at a very complex interface where we're trying to break boundaries and the frontiers of interacting physically with the brain, and in the shadow of synthetic intelligence starting to find real traction and emotional connection with human beings and augmenting us to the extent where people feel threatened by it. It's a fascinating space. You're existing within this phenomenal campus of technology and intelligence, and you're seeing these students move through, and you're giving them this pragmatic, grounded view of the world, which is really refreshing. But I want to ask you, do you believe AI will take humanity to a utopia or dystopia?
I would rephrase the question, if you allow me. Are humans using AI to create a utopia or dystopia? Because AI is just a tool, like a hammer. And you can create something really beautiful, or you can destroy yourself. I mean, maybe again, it's my pragmatic, very simplistic view. I think we as humans, we just need to make a decision to which extent we want to outsource ourselves into something which makes our life easier or not. So I think it will be, as always, it will be both. For some people, it will be utopia. For some people, it might be dystopia, but I hope for the majority is a blend depending on the application. Not I hope, that sounds weird. I hope it will be a utopia for everyone, where people, however, focus on the people, that people get what they deserve, and not so much the AI. AI is the tool again. So I see it very positive, but we need to control human damage. I'm less concerned about AI damage. I'm more concerned about humans making the right decision and not making decisions for the wrong reasons, which are maybe just too short term. Again, we go back to this conversation about we need to understand what's the right thing to do, and then we need to follow through. Much easier said than done. I give you this, but we just need to make this decision as humanity, Or, going back to, again, the government, just working together closely and not outsource all of this to a few individuals, which may make decisions which are not for the benefit of humanity, if we want to say it,
We are in a computer game.